Hi, I just wanted to take this time to say thank you for coming to our presentation today. This is about the dam that is located within our community. So I'd like to take a moment to introduce myself. My name is Heather Crary. I am the emergency manager here, and I have gathered you all here together because I have several different responsibilities as an emergency manager for this community. One of my main responsibilities is to make sure that I reach out to the public and the community involved and let you know of potential hazards or any dangers, and also possibly any way that you can better understand and educate and prepare yourselves in the event that there is some unforeseen or maybe even foreseen disaster that may occur in this area. One of our biggest problems that we have right now is the dam that we have located, which we are all downstream from in the event of potential flooding. So I'd like to take this opportunity to give this brief presentation, and throughout this presentation you'll notice that there's several different things, several different components involved here. The first and foremost will be an overall introduction to dams, what their functions are, some statistics worldwide, and then also some statistics within here in the US. There are several organizations that are involved in dam safety and regulation. We're going to go over a little bit about them as well, and just the strides that they've made in the recent years in improving dam safety and regulations. So that being said, throughout this presentation, I'll give some examples of different things that could go wrong and cause the dam to fail. It's something that none of us like to think about, but it is a very real concern that we need to be aware of. It is important that we are prepared in the event that something like this should happen, and also as a community that we are aware of what each entity is doing. Obviously, we'd have many different response agencies to come and aid us, but as we've learned in the past, if we are aware of what's going on and also the proper channels within which to operate, it'll be a much smoother transition for everyone. And if at all possible, if we can prevent this disaster from occurring in the first place, we're going to go ahead and try to do that. And then we can mitigate any need for any sort of major response. So you'll see a lot of different terms and a lot of different agencies that will be mentioned within this presentation. And as always, I hope that this is the first of many different community meetings, not just on dam safety, but and other hazards that may affect our community. I would like to specifically invite you to contact me if at any point you have any additional concerns, or if you feel that you'd be much more of an active participant and you would like to find out how to go about doing that. I invite you, I welcome you to do that, and I hope that you enjoy the presentation that we have here today. So thank you. High hazard potential, HHP. Dams with this classification are those where failure or misoperation have a probable cause of loss of one or more human lives. ICOLD, International Commission on Large Dams. EAP, Emergency Action Plan. USACE, United States Army Corps of Engineers. Piping, internal erosion caused by seepage. ASDSO, Association of State Dam Safety Officials. Probable maximum flood, PMF, the probable maximum flood that could conceivably occur at a particular location. Taking only the approximately 36,000 large dams listed in the World Register of Dams, there have been around 300 reported accidents. Although the overall failure rate of dams is around 1%, a time-related analysis shows that this has been reduced by a factor of 4 or more over the last 40 years. Increased safety and reduction of incidents is largely due to the improved dissemination of information. ICOLD was founded in 1928 after realizing that many of the incidents that occurred concerning dam safety can be prevented in the future through lessons learned. There are at least 14,726 high hazard potential dams in the U.S., according to the February 2013 National Inventory of Dams, compiled by the U.S. Army Corps of Engineers, with data from state dam safety officials and other sources. Of those 14,726 HHP dams, 3,172 dams do not have an emergency action plan to guide emergency response. Another 2,700 HHP dams are not required to have an EAP, primarily because they fall outside state laws and regulations that are often inadequate to properly safeguard public health and safety in the event of a dam breach. ASDSO's origins date from November 1977, when 39 people were killed by the Kelly Barnes Dam failure in Toccoa Falls, Georgia. President Jimmy Carter immediately issued an executive order directing the U.S. Army Corps of Engineers to inspect dams nationwide. This 3-year Phase 1 program revealed deficiencies in the great majority of non-federal dams. On the heels of Phase 1 inspection, 2 investigations by the National Academy of Engineering and FEMA revealed the inadequacy of state dam safety laws and programs. Their reports recommended an interstate forum on dam safety. ASDSO began with the organizational meetings in 1983 in Orlando, Florida, and Lexington, Kentucky. By February 1985, 37 states and Puerto Rico had officially joined the association. ASDSO's membership stood at 165, 90 associate government employees, and 75 affiliate. Frequent causes of dam failures. Overtopping. This is the most common failure mode, accounting for 34% of the failures in the U.S. over the last 75 years. Many older dams were originally designed for flood events that no longer represent a remote flood event. Many dams cannot pass the current probable maximum flood without overtopping. Most embankment dams would likely not withstand sustained overtopping of a foot or more without a high probability of failure. While most concrete dams can likely withstand a certain level of overtopping due to their rock foundations, some may be vulnerable due to the jointing and fracturing in the rock mass. Reclamation evaluates both embankment and concrete dams for the overtopping failure mode.
Dams are designed to store runoff resulting from heavy rain. When storage has reached a specific limit, spillways are designed to pass the excess floodwaters, initially through a primary spillway. Many dams are equipped with an emergency spillway to help pass large flood inflows which exceed the capacity of the primary spillway. In an extreme flood, flows can exceed the combined spillway capacity, spill over the top of the dam, and create a very dangerous situation. Overtopping flood flows can rapidly erode down into an earthen embankment dam, leading to an uncontrolled release of the stored waters and causing catastrophic flooding downstream.
Overtopping possible causes. The picture is of Greensboro, North Carolina's Lake Townsend Dam, which suffered from a severely deteriorating spillway and inadequate capacity for the spillway to handle large storm flow. The picture to the right is a visual illustration of debris to the right of the concrete wall. This view is from the reservoir side of the old spillway at the Garden City Mine in Michigan. Excessive settlement of the embankment or internal erosion of embankment material may cause a depression on the top of a dam. Foundation spreading upstream and or downstream, prolonged wind erosion, or improper final grading following construction may cause a low area in the crest of a dam. Foundation defects. Foundation defects are the second largest cause of dam failure, almost 30%. They include settlement and slope instability. This picture is of Lake Delhi Dam in northeastern Iowa. It failed after engineers attempted to drain 2 feet off the lake. This action resulted in complete foundation failure. Illustrated here are 2 different types of foundation defects: longitudinal cracking on the left and slide, slump, or slip to the right.
One of the most serious dam safety concerns is the stability of the earthen embankment. Unsafe conditions could lead to a major slide that threatens the safety of the dam. A key factor to stability is the location of the phreatic line, or the fully saturated zone of the soils within the embankment. In safe dams, this level is well confined below the surface. Since soils that are fully saturated are not as strong, a higher phreatic line can reduce the ability of the embankment to resist sliding. This is often noted by seepage exiting on the downstream face of the dam. Weak or poorly compacted soils can increase both seepage and the phreatic level, as well as weaken the embankment, contributing to a sliding failure of the dam. Properly designed dams often include an internal drainage system, such as a sand chimney and blanket drain. They serve as a filter to keep seepage from moving any soil, as well as allowing seepage to be removed in a controlled fashion. This lowers the phreatic line and improves the stability of the embankment. For existing dams with a high phreatic line, two alternatives can improve the dam stability. One is to add a drain near the toe to both filter the seepage and lower the phreatic line through a controlled release of the seepage. The second is to add a berm for added resistance and improved stability of the embankment. This does not lower the phreatic line, but improves the dam stability by adding weight to prevent slides in the embankment.
Piping. Piping. This is internal erosion of the dam caused by seepage. Seepage often occurs around hydraulic structures, such as pipes and spillways, through animal burrows, around roots of woody vegetation, and through cracks in dams, dam appurtenances, and dam foundations, often seen together with foundation defects. Here are some other examples of piping.
Most all dams experience seepage to one degree or another. While the dam experiencing seepage may appear in sound condition, there may be damage occurring to the internal structure of the dam. If seepage flow rates appear to be increasing and the flow is not clear and is carrying material, internal erosion or piping is likely occurring. Piping is an erosion process that occurs inside the dam whenever the seepage flow starts eroding embankment materials out of and away from the dam. This starts at the downstream slope or toe and moves rapidly upstream to the impoundment. This process will tend to accelerate as the expanding larger opening or pipe allows for increased seepage flows. If left unattended, the seepage flow and progressive internal erosion will soon get out of control. When the internal pipe or void becomes large enough, the embankment structure above it will collapse. This will result in a failure of the dam's embankment and a potentially catastrophic release of the stored water, which may cause serious property damage and loss of life.
Other factors that can contribute to dam failure: structural failure of materials used in dam construction and inadequate maintenance. This is a visual aid with a chart for causes of dam failures. As you can see, overtopping far and away is the most frequent. So overall, whose responsibility is it? Who is actually responsible for the safety, maintenance, and upkeep of the dams? Ownership makes dams a unique part of the national infrastructure. While most infrastructure facilities, roads, bridges, sewer systems, etc., are owned by public entities, the majority of dams in the U.S. are privately owned. A dam's owner is solely responsible for the safety and liability of the dam and for financing its upkeep, upgrade, and repair. Many different types of people and entities own and operate dams. About 58% are privately owned. Local governments own about 16%. State agencies own about 4%. The federal government, public utilities, and an undetermined interests own smaller numbers of dams. So where does all the funding come from? There are some major funding problems. Lack of funding for dam upgrades is a serious national problem, especially within the private sector. Operation, maintenance, and rehabilitation of dams can range in cost from the low thousands to millions, and responsibility for these expenses lies with the owners, many of whom cannot afford these costs. Although some states offer loan programs, funding assistance through government or private sources, it is still minimal at best. How much funding is really necessary? In 2009, an ASDSO task group concluded that it would take approximately $34 billion to rehabilitate the nation's non-federal dams, $16 billion to rehabilitate the nation's most critical dams that are in need of rehabilitation, and roughly $8.7 billion was needed to repair the publicly owned high-hazard potential dams, with the remaining $7.3 billion needed for the privately owned high-hazard dams. In December 2012, the task group revised the estimates. Current figures place the total cost estimated for non-federal dams at $53.69 billion. High-hazard potential dams are estimated at approximately $18.2 billion, which $11.2 billion for publicly owned and $7 billion for privately owned. In light of the fact that funding is such a major problem, what is there to do? As a community, it is important to practice emergency preparedness and public awareness. Overall, emergency preparedness is improving, with the percentage of high-hazard potential dams with an EAP increasing from 35% to 69% between 1999 and 2012. The goal is for all high-hazard potential dams to have an EAP, so that dam owners and local authorities are prepared for a sudden dam failure and the ensuing downstream consequences. The ordinary citizen is unaware that the beautiful lakes on which he or she boats, skis, or fishes are only there because of man-made dams. Developers build and dam break flood inundation areas, knowing nothing about the potential that upstream dam has to cause devastation should it fail. In fact, some developers and zoning officials are completely unaware of dams within their community. Even if citizens understand and are aware of dams, they can still be overly confident in the infallibility of these man-made structures. Living in dam break flood-prone areas is a risk. Public awareness. Many dam owners do not realize their responsibility and liability towards the downstream public and environment. Adequate understanding of proper dam maintenance and upgrade techniques is a typical problem among many owners across the United States. Some groups put forth the message that dams are bad for the environment and advocate their removal. This may mislead the public into thinking that taking care of our dams is a worthless cause. In some cases, dam removal is the best solution, but in all instances, the consequences should be considered in coming to this decision. What can you do to help? The first thing is to develop an EAP. EAP effectiveness can be enhanced by a uniform format that ensures that all critical aspects of emergency planning are covered in each plan. Uniform EAPs and advanced coordination with emergency management authorities should facilitate a timely response to a developing or actual emergency. Organizations and individuals who own or are responsible for the operation and maintenance of dams are encouraged to use these guidelines to develop, update, revise, and exercise their EAPs. The level of detail in the EAP should be in line with the potential impact for a dam failure or operational incident. A dam with low or no potential impact should not require an extensive evaluation or be subject to an extensive planning process. High and significant hazard dams may require larger emergency planning efforts and tend to involve more entities that must coordinate responsibilities and efforts to effectively respond to any sort of incident. EAPs generally consist of 6 elements: notification flowcharts and contact information, response process, responsibilities, preparedness activities, inundation maps, and additional information in appendices. In EAPs specific to dams, dam owners should also include procedures in the EAP for ensuring that emergency management authorities are provided with timely and accurate information on dam conditions during the incident. This information will help agencies make the appropriate decisions on evacuations. Evacuation procedures are of vital importance and include the initiation of emergency warning systems, pre-incident planning, identification of critical facilities and sheltering, evacuation procedures including flood wave travel time considerations, distance and routes to higher ground, traffic control measures, and traffic routes. They also include potential impact of weather or releases on evacuation routes, such as flooded portions of the evacuation route before the dam incident occurs, vertical evacuation, sheltering in place, emergency transportation, safety and security measures for the perimeter and affected areas, as well as re-entry into affected areas. There are 4 classifications to the warning system: high flow, non-failure, potential failure, and imminent failure. High flow. The high flow emergency level indicates that flooding is occurring on the river system, but that there is no apparent threat to the integrity of the dam. The high flow emergency level is used by the dam owner to convey to outside agencies that downstream areas may be affected by the dam's release. Although the amount of flooding may be beyond the control of the dam owner, information on the timing and amount of release from the dam may be helpful to authorities in making decisions regarding warnings and evacuations. Non-failure. The non-failure emergency level is appropriate for an event at a dam that will not, by itself, lead to a failure, but requires investigation and notification of internal and/or external personnel. Examples are 1. New seepage or leakage on the downstream side of the dam, or 2. Presence of an unauthorized personnel at the dam, and 3. Malfunction of a gate. Potential failure. The potential failure emergency level indicates that conditions are developing at the dam that could lead to a dam failure. Examples are 1. Rising reservoir levels that are approaching the top of the non-overflow section of the dam. 2. Transverse cracking of an embankment. And 3. A verified bomb threat. Potential failure should convey that time is available for analysis, decisions, and actions before the dam could fail. A failure may occur, but predetermined response actions may moderate or alleviate failure. Imminent failure. The imminent failure emergency level indicates that time has run out and the dam has failed, is failing, or is about to fail. Imminent failure typically involves a continuing and progressive loss of material from the dam. It is not usually possible to determine how long a complete breach of the dam will take. Therefore, once a decision is made that there is no time to prevent failure, the imminent failure warning must be issued. For purposes of evacuation, emergency management authorities may assume the worst-case condition that failure has already occurred. Maintaining the EAP. After the EAP has been developed, approved, and distributed, continual reviews and updates must be performed. Without periodic maintenance, the EAP will become outdated and ineffective. Public awareness. These measures typically explain the proximity of the dam, how people will be informed of an emergency, and the actions people should take during an emergency. There are many different ways to provide public awareness. Some of the ideas would be community events at or near the dam, input and feedback with community leaders for purposes of maintaining the EAP, use of the public in training drills, mailers, brochures at public buildings, websites, social media. Presentations like the one you've sat through here today are also another good idea and another way to reach out to the public to get ideas and feedback. I'd like to thank you all for your attention as we work together to make our community safe